Hey guys, this is Srinidhi here and welcome to my video about booting process. I learned a lot about booting process during this lockdown and I'm here to share some information and some knowledge about my booting process with you. First of all, I thank my faculty, Ms. Maheshwari ma'am, for giving me such an opportunity to share my understanding and learning with others. Hope you find this interesting and get benefited out of it. So, in this current era, amidst all this lockdown and pandemic, and obviously if it was not there too, the youngest generation is fantasized with the newest gadgets in the market. For example, we have a lot of smart watches, smart TVs, and whatnot. Everything else is there smart on the market. So we need to get smarter than these smart gadgets in order to know what is behind them and how it works. So for every device that's there in the market, one of the most important thing that we need to know about is how to operate them or the operating system. And for an operating system, one of the essential features is booting process. You need to understand how the operating system boots and runs. So what are we waiting for? Let's dive in. What is booting? So booting is the part when you switch on your system or when you provide power to your system. For example, when you want to, log into your system, you will press that small button on the top right hand corner of your system. Let's say that's the power button. Sometimes there are people who would want to start the system using a software command. So that is also possible in booting. Did you know that the CPU does not store any software in its main memory? So whatever software that you want the system to execute, let it be a small C program or a or a text file or whatever, or even the operating system, it needs to be loaded into it needs to be loaded into the main memory of the CPU through a special software or an external software called the loader. And when this loader loads the operating system into the CPU's main memory, it is given a special term called the bootloader or a GRUB. GRUB is used in most of the Linux distributions, so we'll use the word GRUB here, but it is generally a bootloader. That is, it loads the operating system into the CPU's main memory. So coming back, what is booting? Booting, as I said, is when you switch on the power button of your system. And did you know there are a lot of processes that happen during booting? Sometimes when we are in a hurry, for example, when we need to submit an assignment or we need to watch a movie, we get bored seeing the long running, the looping button when the system gets booted. But sometimes when you need to do a drudgy work you're not interested in, we find the operating system boots in a fraction of a second. But actually there are a lot of processes going behind during booting. So before going on to the process diagram or the flow diagram of booting, I would like to give a small mention about the different types of booting. There are different modes in which an operating system can be booted. For example, you have a single mode, you have a multi-mode, you have a dual mode, etc. Here I've given you two images of booting process. So here in both the images, it's a multi-mode of booting. So a multi-mode booting is when the system gives you a choice of what operating system you want to boot. So, okay, let's keep it simple. Let's go from the simplest to the hardest. So, first is a unimode booting system. For example, if you take my system, it has only a Windows software and I use Linux version as a virtual machine. So when I press the power button and I give my credentials like my password and all, it doesn't give me an option of what operating system I want to use. It just has a single operating system and it boots. When there is more than one booting operating system that is present on your system, it gives you an option. As you can see here, it asks you to choose an operating system. Like you can choose Windows 8, you can choose Ubuntu, you can choose Mac OS, or whatever operating system you want to work with for the current period of time. So that's called multi-mode booting. There is also something called dual mode booting, which is a version of multi-mode booting where you have two operating systems. You can also call this partial booting. So next, moving on to a flow diagram. So this is the flow diagram or the different processes that take place during booting. First is the BIOS integrity check. BIOS stands for Basic Input Output System. Your basic input output system consists of your screen, your keyboard, your mouse, the hard disk, and other devices that you use. Integrity check is normally done using something called a post, which we'll see about later. So don't worry if you don't understand any of the terminologies here. We're going to look at everything in detail in the upcoming slides. So don't worry. It's just an overview or a bird's eye view of what we're going to see in the next 10 minutes or 12 minutes. So here, first is an integrity check, which sees if all the hardware devices connected, for example, your mouse, your hardware device, your hardware disks, or your keyboard, or whatever that you've connected externally with the system is working fine. And then it moves on to the master boot record, which executes the GRUB or the bootloader, and then the GRUB executes the kernel. I hope you know what a kernel is. So it's the main, it's like the mantelpiece of an operating system. It's the heart of an operating system, if you want to put it in a layman perception. So it provides a lot of functions for you to access the operating system through system calls and other things. If you want to know more about kernel, you can look at separate videos. I've focused only about the booting process here. I'm not talking about the kernel now. And then the kernel executes the initialization file or the init file. The init file initiates the run level of the operating system. Run level of the operating system decides at what stage or what initial level the operating system must boot, and it executes the run levels. So this is the basic overview or the flow diagram of an operating system's booting process. So now, categories of booting. So before we move on to the different processes and terminologies associated with the booting process, we'll look at the different categories of booting process. As you can see in the pictures, you can guess from it, like one is the winter symbol, which is my favorite. And then one shows the temperature and there's a sun and all. So as you can see from these pictures, you can infer one is a cold booting and one is warm booting. Cold booting is also referred to as hard booting. It is when the power is cut off to the system. So in this case, the system starts from a dead state, completely dead state. For example, when you're working on your system and there's a sudden power shutdown in your area, or the power cut to your or the charge in your laptop gets cut, then the system goes to a dead state. So when you then connect your power cord or your auxiliary power cord or some power machine to your system and it starts booting, it starts from a completely dead state. The changes that you have done to your files, or if you have any unsaved files, might not be there. For example, the main crux that I want you to understand is that the system does not start from the state you left when it got shut down. So this is hard booting. Soft booting is quite opposite to that of hard booting, and you can infer it is the booting that happens when the power is not cut. For example, when you leave the system in an SSD mode, or when you lock the system in layman terms, the system is not completely shut down, like the system is not completely dead. It saves the current state of the system. That is, it saves what all the files are open, whatever changes you have made, whatever unsaved files you have, and then when you lock the screen, it just switches off the display or the screen, but internally the processes are still running. So it's not a complete dead state. So when you reboot the system from the lock state, it brings down all the saved changes that it has saved to the memory. It brings in, and the original state at which you lock the system is regained. So these are the two different categories of booting process. So let's move on to the different terminologies of booting process. So first, as I said, is the BIOS integrity check. BIOS is basic input output system, and the integrity check is also called the power on self test, in short, POST. So for example, there is a class. So when the teacher would like to start the class, she might want to take the attendance or roll call of the students present. She might want to know what are all the students are present, so that she can mentally make up the, mentally make her mind up for the number of students and what are the topics she should cover today. So she starts calling all your names or all the students enrolled in the class. And if you are present, if your name is called, you say yes. If someone is not present, there's a silence, and the teacher understands that that person is missing. So that scenario is analogous to what happens in power on self-test or POST. Power on self-test is nothing but, it tests whether all the hardware devices that are connected to your system, all the peripherals connected to your system, are in a proper working state. Whenever the system is switched on, whether it is a cold boot or a hard boot or a warm boot or a soft boot, this post happens. It sends a signal to all your hardware devices, and the devices send an acknowledgement back. It's like, you answer, you say present ma'am, yes ma'am, no ma'am, what something when your teacher calls out your name. So that is what is the acknowledgement. It's nothing but a response to the operating system, and it says, hey, I'm there, I'm still working. So if the acknowledgement works, if the acknowledgement that the device sends is not corrupted, and if there is an acknowledgement first of all, then the operating system understands that the device is working. It understands that, oh yes, there is a device. If there is no acknowledgement, then it is removed from the system. The operating system recognizes that the hardware is not working and it removes it. So if you do not answer to the roll call of your teacher, if you stay silent, what happens? The teacher takes it as you are absent. You are not given your attendance for the day or for the class. If there is an error or if there is a corruption in the hardware disk that you're using, a beep sound is generated and the error code is displayed. So for example, you are physically present in the class, but you forget to answer for your attendance or your roll number or whatever. What will you do? After the teacher finishes the whole roll call of all the students present in the class, you raise your hand, you walk up to her and say, ma'am, I was present, but I'm sorry, I was not able to answer your attendance. I was quite preoccupied. So that is what happens here. If there is an error in the hardware device that you've connected or the peripheral that you've connected, the operating system says, hey, the peripheral that you've connected has, seems to have an error. So please check it. So it does not start the operating system, it waits, and once the error code is resolved, it starts. Or if you say, okay, I do not need that peripheral, you can assume it to be as removed from the system, then the operating system removes it from the system and starts booting. So this is power on self-test. So next is the master boot record. Master boot record is the first section of any hard disk that is present. The master boot record stores the GRUB or the bootloader. It is one of the vital or essential part of any hardware system. It's the first sector in every hardware system, and this is quite important. The master boot record has the GRUB or the bootloader, which is very essential for the operating system to run in a proper manner, because the bootloader is the one that is going to load the operating system properly into the memory of the CPU. It is the one that is going to read the files that are required for the operating system to run properly through the ROM. So this is one of the most important record that is present. That is why it is called the master boot record. It's called the master boot record because it's the most vital, it's the most essential record that needs to be placed, and that's why it's placed as the first record in any hard disk that you have. It's called boot record because it helps in booting process. The master boot record is divided into 4 major sections or partition tables. The last partition table can be extended or can be subdivided into smaller partitions depending on your choice. As you can see here, there are 4 different partitions. There are boot code, partition table, end of MBR, and the partition types. The end of MBR is the one where you can extend it, you can subdivide it and go on. And so the master boot record has totally 512 bytes. The first 446 bytes is the primary information about the bootloader, and this is one of the most vital things. You have to maintain it so that it does not get corrupted. It's one of the most secure files in any hard disk. You cannot read or write the master boot record without proper access permissions. And the next 16 bytes are for the the next 64 bytes are the partition table information, and the last 2 bytes are the MBR validation checks. The MBR is also referred to as sometimes the partition sector or the master partition table. It has 4 primary partitions, as I said, and it has the information about GRUB. It is in the first sector of any hard disk. It indicates how and where an operating system is located so that it can be loaded into the computer's main memory or the random access memory. In short terms, it stores the GRUB. So this master boot record locates the GRUB or the bootloader and starts executing the bootloader. The bootloader executes the kernel, and the kernel executes the initialization process. The initialization process, or in short init process, is the one that is the last process of the booting process. It is last but not the least. It is the one that decides how your system should boot and at what run level. So a run level is nothing but, you can say it is a mode. It's called run level because it decides the level at which your booting process happens. So there are different run levels. You can access the init file at the init tab.file under the etc directory of your hard disk, but do not make changes to it because it's one of the most important files. You can also identify the default run level using the command that I've given below, grep init default etc init lab. You can use this also. And so the different run levels or the modes are, if you have run level 0 as your initialization process, then it is the shutdown mode. It shuts down the system. When you give Alt F4 or when you manually go and shut down your system, the run level is set to 0 and the shutdown action takes place. So when the run level is 1, it is a single user mode. In Linux distributions, we call it the maintenance mode. When there's a single user logged into the system and he's maintaining it, that is, he'll make changes to the login files and all those things. Second one is the multi-user mode, but you cannot configure network devices in this second run level. For example, if you have an NAC connector, or if you have an adapter connector, or if you want to access the Ethernet cable, you'll not be able to do it using multi-user mode with run level 2. In run level 3, however, you have the networking device associated, and you also have the command line interface only at this run level. It starts the system normally with all the services which in a text mode interface. That is, remember, it does not include the GUI here. Fourth run level, I do not know for what reason, is not used. Fifth run level is the X11 run level or the X11 mode. It uses the GUI. It starts the system normally with all the services, including the text mode interface or the command line interface, along with the GUI or the graphical user interface. For example, in an MS-DOS operating system, you cannot expect run level 5 because it does not have a graphical user interface. It starts only with the run level 3. For example, in a Windows OS or in the Mac OS, you can expect the system to start with a run level 5 as it has a graphical user interface. Run level 6 is when you reboot the system, and you know what happens in a reboot system. That is when I said it saves the current state of the system and starts the booting process from scratch. So usually the operating system stays at either 3 or 5 or the 5th run level depending on the operating system that you're using. As I said, if you're using a MS-DOS operating system, then the run level stays at 3, and if you're using a Windows or a Mac OS system that has a graphical user interface, it is default set to 5. So a quick recap of what we saw. First, we saw that the BIOS takes place, or the basic input-output system executes the master boot record, which we have seen. It executes the post self-integrity check, where it recognizes all the hardware that are connected with it and sees if all the hardware on the peripherals or the input-output devices connected are in proper working condition. It then executes the master boot record after locating it. Master boot record, as I said, is the first sector in every hardware device, so it's not quite difficult to locate it. The master boot record executes the GRUB or the bootloader. The bootloader is the one that loads the operating system into the machine that you're using, and therefore it's called the master bootloader. So the master bootloader initiates the bootloader, and the bootloader starts executing the kernel. The kernel is the mantelpiece of the operating system. It is the one that allows you to make system calls. It is the one that is present at the lowest level or the lowest level of abstraction of any operating system. The kernel starts executing the init file. The init file executes the run level program. The run level program is the one that decides at what run level or what initiation level should your operating system start. And the run level program is executed from the init file, init tab file, as I said. And this is the one that decides at what initiation level should your computer or your system start. So till now we've seen success stories, like we've seen like if the post works successfully, all the hardware devices and the peripherals connected with the system are properly working, the system locates the master boot record and starts initializing the bootloader, and the bootloader executes the kernel if there is no error with the bootloader, and the kernel, if it does not find any error or if it's not corrupted, starts executing the init file. The init file runs the run level of the program. If it finds the run level properly, for example, if you give the run level to be 7 or 10 or something, it does not find the run level, and so it does not execute the init file. So what happens in such cases? What happens when there's a failure with the bootloader or with the booting process? So if the computer cannot boot, you will get a boot failure error. This error indicates the computer is not passing the post or the power on self integrity test, or a device in the computer such as the hard drive, or sometimes even your main memory or random access memory has failed. You may also hear a beep code to identify which hardware is failing during the post. An error message or sometimes a blue pop-up screen may appear on the operating system and show that the file cannot be loaded due to what reason, due to not being found or being corrupt or whatever. So for example, I've given two images here. The first image says the blue pop-up screen, boot failure. A proper digital signature was not found. One of the files on the selected boot device was rejected by the source secure boot feature. It says that the file that was selected from the hardware for the booting process was not proper. It might have been corrupted, it might have got certain changes made, or the secure boot feature, that is the level of security in the booting process, might have found the file that you have given to be of a lower secure feature. So that is what is meant in the first image. The second image says disk boot failure, insert system disk and press enter. So it says that it is not able to identify the system disk or the hardware that you've connected with the system. It means that the hardware or the peripheral that you've connected with the system is not working properly and it has not passed the post. From these two images, you can see that the operating system tells you what the error is so that you can fix the error and start rebooting the system. So this is what happens during failure of a booting process. So for those of you who felt that all my, the whole PPT was full of theory, it was like full of images and you didn't find quite notes for it, here is the notes part. And let me give you a quick recap of what we saw now. What is a booting process? Booting process is the process of switching on a CPU from the time the power is supplied to the time when the OS starts executing. There are two categories of booting process, hard booting and soft booting. Hard booting is when the power to the CPU is switched off and booting starts from a completely dead state. For example, when your laptop power goes off or there's a power shutdown in your area. Soft booting is when the power is not cut, but maybe the RAM might be cleared to zero. This is when your device goes into an SSD mode or when you lock your device. And then we saw about the power on self test or post, which checks the hardware device's working conditions and reports if there are errors or faults. And then there's the master boot record. It is the first sector of any hard disk and indicates how and where an operating system is located. It holds information about the bootloader and has three components. The first one is the primary bootloader, which is 446 bytes, partition table, which has 64 bytes, and MBR, which is 2 bytes. And it has an extra component, which can be subdivided into other partitions if required. And then there's the init process or the initialization process, which is the last but not the least step of the booting process. It decides the run level by looking at the init tab file on your system. So thank you for your learning. Thank you so much. And I think I've shared some useful information which will help you in resolving all your doubts and queries about booting process. Thank you so much.